Okay, here's a problem I've been working on with a student. It reads, two wheels with radius 1 meter are connected by an axle with a radius of half a meter. The wheels and axle roll as a single rigid body. One half of a 10-meter long rigid thin rope is wrapped around the axle. The rope is wrapped such that the free end of the rope passes under the axle as shown. Point A at the free end of the rope is pulled parallel to the ground at a constant speed v, causing the wheels to roll without slipping. And basically the question is what happens. The idea is, first question on this, the multi-part, but first question is, does the wheel roll towards the point A or away from point A? Okay, so you have to kind of think about this. Now, the problem does not say whether or not the system starts at rest. It does not say how it gets to a constant speed v. It does not say if the ground is level. A couple of things that are missing here. If you assume that it starts at rest and it is brought to a constant speed by pulling on the rope, that is the most logical way of interpreting the question. So that's what we'll look at first. Okay. What I have here is a little mock-up of the axle, and I have it on this board. Okay, now it turns out this board is actually tilted. Okay, the reason I did this is because when it's tilted, the wheels can move. Let me just straighten the wheel out a little bit here. Okay. Now, it just gives a little bias in it. The wheels will roll to the right if I just let them. Okay. And one solution to this problem, as phrased, is the idea that the wheels could be put in motion by rolling downhill, even if only for a slight instant. Once they're rolling to the right, I can simply follow them rolling just by following along at half of the speed, okay, as it unrolls. Okay. Another solution of this is the wheels are put to a constant speed by a pull towards them by the string. Okay, in which case it would continue to roll that way, and I could roll up the axle by moving away at a constant speed. And it's a little bit difficult to do this demo exactly correct because you can see the way my string is rolling up. Okay. This, when it's on a slight tilt, I can make it go in either direction, which is kind of the advantage of doing it this way. I can show that it's rolling at a constant speed, let's say up. In fact, rolling at a constant speed up, I'd even have to pull on the rope if it was uphill because it has to work across the force of gravity. And then a constant pull at a constant v could be produced with a constant force on the rope. Okay. Now, what I'll do is I'll hit pause and I'll show you this scenario. If it's level, if it's really level, it's harder to have the solution where it's just rolling by itself to the right because it's not going to continue to roll by itself. It's not going to unroll, okay, because of there's not enough friction. Okay, so what I'll do is I'll hit pause and I'll make this level. Okay, here the ground is level, okay? The wheel is at rest, it's not rolling. If you put this into motion by pulling on the rope, it will move towards the rope, okay? And you would have to move the rope to the left at half the speed in order to keep that no slack would develop along the rope. Okay. And once again, you have the same problems. Now, likewise, if this was put in motion by setting the wheels to spinning, okay, it would just continue to roll to the right, and you'd have to follow along at half the speed to allow the rope to unroll. Now, I can't do that here because it's not. It's perfectly level and there is friction, although in the problem there's no friction, okay? So there's actually two solutions to this problem. One is that the wheels are rolling to the right and it's unrolling and you're simply following along. It was put into motion at a constant velocity v by pushing the wheels, not the rope. The other solution is that it's initially moving, let's say, to the left. That could either be done by pushing the wheels to the left, or it could be done actually by putting it in motion by pulling on the rope. Okay? And that's the one that's almost certainly intended by this. Okay? This is the way this type of machine is designed for that purpose, to pull something towards you. Okay? Anyway, that's just a little demo of this physics program.